In the previous video on critical thinking, we discussed what we mean when we say science. The way science is usually conducted is through scientific experiments. The experimental method helps to assure that the data we get from our experiments is more likely to be accurate. In this video, we'll discuss what the experimental method is and how it works. The first step in the experimental method is to come up with an experimental hypothesis. This is the theory to be tested by the experiment. It should be something that is falsifiable. In other words, the hypothesis should be stated in such a way that it can be disproven if the experiment fails to support the theory. So for example, if I'm testing a new drug for cancer, then the experimental hypothesis might be drug X improves cancer symptoms. If the experiment is conducted and drug X fails to improve cancer symptoms, then the experimental hypothesis is rejected. This leads to something called the Null Hypothesis. The Null Hypothesis is just the opposite of the experimental hypothesis. In the drug X example, the Null Hypothesis might be drug X has no effect on the symptoms of cancer. Or it could even be that drug X makes cancer symptoms worse. If we conduct the experiment and drug X improves cancer symptoms, then we reject the Null Hypothesis. If we conduct the experiment and drug X has little or no effect, then we retain the Null Hypothesis and reject the experimental hypothesis. So how do we know when conducting an experiment that it was drug X that made the symptoms better and not some other factor? What if the people taking drug X also had a healthier diet, and that was the reason that their symptoms improved? Experimenters try to control for such variables by having a control group that doesn't receive drug X. So a group of participants is randomly assigned to either be in the group that receives the drug or to be in the group that receives a placebo. The group that receives the drug is called the experimental group, and the group that receives the placebo is called the control group. Participants are assigned to each group randomly so that the experimenters can't influence the outcome. Random assignment acts to minimize any biases the experimenter might have regarding which participants should be assigned to which group. The more variables that can be controlled in this way, the more likely the results of the experiment are to be accurate. There's also different types of experiments that scientists could conduct. Lab experiments offer the most control over extraneous variables because when an experiment is conducted in a lab, the experimenters can more readily control what happens to the participants. The problem with lab experiments is that what happens in the lab isn't always the same as what might happen in the real world. People behave differently in labs than they do in the real world. That's where field experiments come in. Since people don't act the same in the lab as they do in the real world, a lot of experiments are conducted in the field. A field experiment can be a great way to see how people respond in the real world, but it does make it more difficult for the experimenters to control the variables. For example, there's few ways to randomly assign people to control an experimental groups in the field. The third type of experiment is a quasi-experiment. Quasi-experiments are sometimes referred to as natural experiments because there's no way to control the variables in this type of experiment. Instead, the results are determined by the natural conditions of the topic being researched. For example, suppose I want to study the effects of birth order on personality. I can't dictate the order in which people are born, and I can't determine what sort of personality a person will have. All I can do is to study the data as it naturally occurs. The participants in this sort of study naturally fall into the categories being studied, and cannot be randomly assigned to groups. This type of study is used to research natural, real-world settings. So the basic steps of the experimental method are 1. Create the hypothesis, 2. Design the experiment, 3. Collect the data, 4. Study the data, 5. Research your conclusions, and 6. Share your findings. So let's look at each one of these steps in more depth. First, create the hypothesis. To do this, an experimenter looks at the data or situation about a chosen topic and draws tentative conclusions based on the perceived results. A hypothesis is an educated guess about something. 2. Design the experiment. The gold standard of experimental design is a double-blind study in which participants are randomly assigned to either a control group or an experimental group, and the researchers don't know which group the participants are in until the end of the study. But since this isn't always possible for reasons we've already discussed, the researchers look at what design best fits what they're studying, while trying to control for the variables as much as possible. 3. Collect the data. Data can then be collected using forms and surveys, or by experiment or observation, or by dozens of other methods. This raw data is then used to evaluate the experiment. 4. Study the data. Raw data collected in the experiment is then analyzed to determine if the results back up the experimental hypothesis. 5. Reach conclusions. If the data supports the experimental hypothesis, then it's retained and the null hypothesis is rejected. If the data does not support the experimental hypothesis, then it is rejected and the null hypothesis is retained. 6. Share your findings. Most scientific studies submit for publication in peer-reviewed journals. Peer review means that the study is subjected to rigorous investigation prior to being accepted for publication. When a study is submitted for publication, a peer review committee is selected. The members of this committee usually have a level of expertise in the area that the study is about. This peer review committee then looks at the methodology used to conduct the study and decides if there were any threats to the study's validity. In short, they try to disprove the study prior to accepting it for publication. If they can't, then it goes for publication. This peer review process is the final step in the experimental method. Peer review minimizes any tendency toward bias by the researchers by double-checking their work before introducing the results to the scientific community and to the public at large. While it's not perfect, it's still the best way we've found so far to minimize errors in scientific research. So when you're evaluating research or looking at the results of studies, keep these steps in mind. They'll help you to determine how likely it is that the study is accurate. If you like what you're seeing, you can support us by subscribing and clicking the bell icon to be informed when new videos are released. You can also visit our website at bitchite.com. Thanks for watching.